Okay, General Physics textbook problem page 196, number 56. This is a problem that gives a lot of students some issues. There's a hard way to solve it and there's an easy way to solve it. I'm going to go straight for the easy way. All right, I've drawn a little sketch of our given information. We have this 7,200 Newton spacecraft. They were given, that is its weight. That's its weight on the surface of the Earth. And of course, the surface of the Earth is about 3.6 million meters away from the center of the Earth. I already went ahead and converted the kilometers to meters. Now, the hard way to do this is I know the weight, which is the same thing as the force of gravity, and I can do a little bit of back calculation and I can get the mass. I can look up the mass of the Earth, and then I know the mass of the spaceship, and then I can just merely compute the force of gravity at my different altitudes. That will work, but it is a long and tedious process. All right, here's a much easier way to think about it. Okay, so we know the weight when I'm at one radius is 7,200 newtons. Okay, so the first altitude that we have is another 6.38 million meters away from the Earth. So what I've done is I've doubled my distance. So think about the inverse square law. If I double the distance, what does that do to the force of gravity? Think of all of our discussions that we had on how does the force of gravity diminish? When I double the distance, it doesn't half the distance. It quarters it. Okay, now, then the next one, that one was fairly easy. This one here, I can use the same trick. All right, so the next altitude, they tell me here, is 12.8 million meters. And you just go, okay, now how are we going to do that? Well, the trick to this, if you notice that the 12.8 million meters is just yet another radius tacked on there. That's 6.38 million plus 6.38 million. All right, so now this altitude now represents triple my distance from the surface of the Earth. So here I've got my weight at one distance, our radius of 1, and then I'm at a radius of 2. Now I'm at a radius of 3. So for each one, I've doubled my distance. Now I've tripled my distance. Again, think of the inverse square law, and we know how our weight is going to diminish with distance.